again to Chemistry 1407, Lab 5. I'm Wafa Doni.
And this is Akua White.
So, we're going to do, the Lab 5 is about synthesis of biodiesel. Are you guys familiar with the term biodiesel? Ms. White?
Biodiesel is actually made from plant sources. And biodiesel versus the regular diesel is actually a lot safer because it's environmentally friendly and it is biodegradable.
And less toxic.
Right. Regular diesel comes from fossil fuels, so essentially the hope is in the future we'll go away from regular diesel and adopt biodiesel.
So, today's lab will be about synthesizing a biodiesel. So, synthesizing a biodiesel. This is a simplified reaction pathway from the background of the lab content. Here, the main reactants are methanol, calcium hydroxide, and the vegetable oil. So, in the first step of the reaction, this step 1. On step 1, methanol reacts with calcium hydroxide and produces calcium methoxide. Calcium methoxide in this reaction pathway has two very important roles. One will be as a catalyst, and another one will be as a reactant. So, as a catalyst, the calcium methoxide reacts with methanol, produces the catalyst, another catalyst, and as a reactant, calcium methoxide reacts with the vegetable oil, which is essentially triglyceride. Finally, so it produces a complex, and finally, the complex and the catalyst reacts and gives you the final product, the biodiesel. So, this will be the step 2, and this will be the step 3, and this is the final product. Here, biodiesel is actually a kind of a ester, a methyl ester. And the two byproducts are the diglyceride and calcium methoxide. You can see it's a catalyst. It was a catalyst, so it gets regenerated. So this is the simplified version of synthesizing a biodiesel. Here, methyl ester.
Wearing the safety equipment is very important for the lab. Make sure you take the time to get the proper safety equipment. As you can see, we're wearing our lab coats. You are provided with an apron which comes in your lab kit. You're provided with nitrile gloves too, and you are provided with this very nice, handy dandy lab goggles. So as you saw Miss Tony, she adjusted it so it can fit her. Make sure you adjust it so it fits your head. Okay? Looks like we're ready to go for lab.
Yeah. So here you have the reactants, methanol, the vegetable oil, and calcium hydroxide. To do the lab, we need a dropper to take some of the vegetable oils, a glass vial. To measure out the methanol, we need the cylinder, and to do the reaction, we need a glass test tube.
So all of these items come in your kit, so we should all be provided as a kit.
Yeah, with the weighing balance.
And this came with batteries. We already fitted in the batteries, so it should be available.
Yeah, it should be available.
We're going to go ahead and start with the lab activity.
Yes. So first of all, we're going to weigh out 0.02 gram, about 0.02 gram of calcium hydroxide in the weighing balance. So let's put the weighing pen right here. Tare it, and I'm going to try to take about 0.02 gram.
The purpose of tearing is to make sure that you're negating the mass of the weighing bolt. And since we weren't provided with a spatula, we have to use this method to transfer the calcium hydroxide into the dram vial.
So I could not take it as exactly at 0.02 gram. So you guys, when you try it, try to be as close to 0.02 gram. Now I'm going to put the calcium hydroxide in the vial. Meanwhile, Ms. White can measure out 8 ml of methanol.
Since we have the calcium hydroxide weighed out and measured out, I'm going to be measuring the 8 milliliter methanol in the graduated cylinder. So 8 milliliters is right at this level. Make sure you have your goggles on and your gloves for this. So I'm going to pour this in here and stop at 8 milliliters. Oh, I think I spilled a little bit. Okay, right at 8 milliliters. So we got that.
And let's add this methanol to the vial. Cap it and shake it. Shake it really well. It's important that you mix the reactants. Allow these two to mix. Making sure there are no more calcium hydroxide left. Now, let's wait for 10 minutes. Okay, after 10 minutes, let's open up this vial. You have to be careful. Keep it away because pressure might build up. Then we add 1 ml of vegetable oil in it. So this will be the last step. So you have to wait for 48 hours. Before that, make sure to vigorously shake it again. Mix it well.
We will be back in 48 hours.
And then we're going to do a quality testing on the biodiesel produced. Here, after 48 hours of mixing all the reactants, we're here to test the properties, some of the properties of this biodiesel. So first of all, let's see the density. We're going to need graduated cylinder. So let's take about 1 ml of the biodiesel. Biodiesel will be the top liquid layer. So let's do this. About 1 ml. There you go. So you know the volume. From the weighing balance, you can see the mass. So from there, you can easily calculate the density. So what was density again? Mass by volume. Now, let's see the pH of this biodiesel. So simply take a strip of from the pH from the packet, a strip, see if there's any color change or not. And make sure to write down your observation on the data table. Then what else we can do? We can see that this biodiesel mixing with methanol, what would be the reaction? So I have here about 7 ml of methanol weight. Let's take this 1 ml of the biodiesel and let's see, mixing with methanol, does it form any other layer or not? Let's see. So, use your thumb, let's mix it well. So, make sure to write down what is your observation. Do you see any insoluble layer or not? So that's it. That's it for the properties of the biodiesel. Make sure to write down all of your observation on the data table.